Welcome everyone. In this video we're going to learn about remainder theorem. So what's the use of remainder theorem? Suppose we're going to divide a polynomial px, this is px with dx. So this is the divisor and this is the dividend. What is the remainder? Okay, that's what we're going to get using the remainder theorem. Why do we want to know the remainder? I'll start with a simple example. If I'm dividing 18 by 3, I get 6 here and 18, the remainder is 0. So if the remainder is 0, then that means 3 is a factor of 18. The same thing applies in here as well. When I divide px with dx, and if the remainder that I get is 0, then I can say x minus 2 is a factor of it. So we need to often factorize a polynomial because that's required for solving an equation and also to find the x-intercepts and hence to plot the graph. If I want to know the remainder for this particular one, px divided by dx, and what is the remainder of this particular division, I need to perform the division. So it could be either long division or equating coefficients. You can use whichever method preferred by you. But that's of course a long process. Okay, but if there's any quick way of finding the remainder, that's so nice, isn't it? That's what we're going to get in remainder theorem. So let's start with the equation when we divide px on dx. So we have this equation px equals dx, which is divisor, times qx. Qs is the quotient that we get in here, and then plus the remainder. Okay, so that's the equation we already have. And so x minus 2 is the divisor in here. So instead of x minus 2, I'm going to use a general expression. So this is x minus alpha is the divisor I'm going to use, times qx plus r. So this equation for px is valid for every value of x, including alpha. Okay, so I'm specifically selecting alpha because I know if I'm substituting x equals alpha, this term goes to 0. So I'm going to make that substitution x equals alpha, and then this equation becomes p of alpha. I need to make all the x alpha equals alpha minus alpha is 0. So this term, the whole term goes away, equals r. So what I simply get is p of alpha is r when I divide px with dx. So the remainder theorem then says if px is divided by x minus alpha, then p of alpha is the remainder. So the dividend in here was x minus 2, which needed to compare with the x minus alpha, and alpha is then 2. Okay, so by comparing these two equations, so the remainder is r equals p of alpha, which is equal p of 2, and that when we make the substitution of 2 in this px, that's a 2 cube plus 3 times 2 minus 2 equals 8 minus 6 minus 8 plus 6 minus 2. So that's a 14 minus 2 is 12. So this is an easy way to find the remainder when a polynomial is divided by a linear polynomial. Okay. I'll also show you how the generic expression looks like. So when p of x is divided by beta x plus alpha. Okay, this is a more generic expression. So this can include every sort of divisor, even if it's something like 2x plus 1, 3x plus 5, or 5x minus 2, something like that one. Linear expression, but with a coefficient here as well. Okay, and you can also use that for this one. This is a simple version of it. And if that's the expression, how the remainder can be found. So this expression becomes dx is now beta x plus alpha and times qx plus r, and we need to select the value of x when this term is going to be 0. That's when x equals minus alpha on beta. So when you make that substitution, this term goes 0. So you can find the value, you can substitute this value of x in here, so that becomes p of minus alpha on beta equals, when you make minus alpha on beta here, this term goes 0, and then that equals r. So this is a more generic expression. P of minus alpha on beta is a remainder if we divide the polynomial px with beta x plus alpha. Okay, and if you want to do the same problem using this equation, that's also is possible. So remainder equals P of minus alpha on beta. So what is alpha and beta that you need to obtain comparing this equation x minus 2 with beta x plus alpha. So beta is the coefficient of x, which is 1. So beta is 1 and alpha is the constant term in here. So it's a minus 2. Alpha is minus 2. So when we make that substitution, R equals P of minus alpha. So minus of minus 2 is 2 divided by 1 is P of 2, and that equals, when you substitute 2 for this equation, so 2 cube plus 3 times 2 minus 2 equals 8 plus 6 minus 2 is 12, as we got it before. Okay.